In this video, we'll complete a short exercise that will demonstrate how to use several key features of InPanel. What we're going to do is find the correct membrane shape for a barrel vault or saddle-shaped surface, which is technically called an anticlastic shape, and then panel that shape. We'll work from a simple boundary frame which I created earlier in AutoCAD. Let's put it in orbit and move it around a little bit. As you can see, it's made of two arcs in cyan and two lines in white. Now we'll add a basic arbitrary shape mesh onto this frame. The mesh represents the surface of the fabric. At this point we don't care about the shape of the mesh, we just need a starting point, and we'll adjust the shape later. To add the mesh, we'll use the InPanel Model Builder tool. Before using this tool, however, we need to set the options. So we'll go down to Options, and then we'll click on Draw Edge Mesh, since that's what we're doing, and under Mesh Settings we see the Insurf and Imsurf. The Insurf and Imsurf are the number of threads in the mesh, which determine the quality of the mesh and the number of panels. For this model, we'll go with the default settings. Click OK to close the options window. Now click on the Model Builder button. The AutoCAD text window, right down here, is asking us to select the edges of the frame that we want to mesh. We'll select the bottom edge first, then the right edge, then the top edge, and then the left edge. Now we have a basic shape mesh. We'll select this mesh and copy it further down and work some more on it. Let's take our start point and move this whole thing over here. Now we need to find the correct mesh shape to turn our model into a tensile fabric structure. To do this, we'll select just the mesh and then use the InPanel command Relax Fixed Edge Meshes. Relaxing the fabric is taking it towards the force balance shape it will be when it is under an equal stress on all sides. So we'll click Relax Fixed Edge Meshes, and the old mesh will be in red, and the new mesh, the relaxed mesh, will be in white. We'll delete the old mesh by clicking on the InPanel Delete Old Objects button. Each time you relax the mesh, InPanel takes it through a run of 250 iterations towards the correct force balance shape. Select the mesh and relax it again. The correct shape is obtained when the model shows no sign of further movement when relaxing. In a simple model like this, that will generally happen with just one run of 250 iterations. We can see that our model is sufficiently relaxed because the old object, in red, exactly parallels the new object, in white. We can't even see the white because the red is matching it exactly. The mesh hasn't moved at all. Let's delete the old mesh. And here's our new mesh. Another way to see if the relaxation is complete is by checking the residual, which can be found in the InPanel text window. If the residual is below 0.0001, the relaxation is complete. Here it tells us that the residual is exactly 0, so we're good. Sometimes you may want to adjust the loft of the mesh. The loft is a term for how much the mesh is being lifted. To adjust the loft, we'll go to the Mesh Relaxation Options page and we'll change the weft warp stress ratio. We'll try a ratio of 2. This will increase the tension between the arcs. Click OK, and now we will relax the mesh again. And you can see how the mesh is lifted this time. Let's delete old objects. And there's our mesh. Now that we have the desired shape mesh, we need the flat panels, which, when sewn together, will create that shape. We can create the panels by selecting the mesh and using the InPanel Panel a Complete Mesh tool. That tool's right here. We click it, and the panels will be drawn under the mesh in the XY plane. Let's move our original mesh away, copy it further away so that we can see the panels better. Let's put it right here, and then let's delete this one. If it will let me select just the mesh. Let's try that again. Let's delete that. Now we have our mesh and our panels here. These panels, however, clearly have some centerline curvature. Sometimes paneling across the mesh will get us better looking panels. So to try this out, we'll first go to the Options under the Panel Complete Mesh button. And then we'll click Panel Across Mesh instead of Panel Normally. Click OK. And now we will make the panels again. We'll select the mesh, click Panel Complete Mesh, and this time we get much more rectangular panels that run across the mesh. Because these panels have less curvature, they will be easier to make. Of course, this is just a quick example. In later videos, we'll describe paneling in much more depth and explore other paneling options. Now we are finished with our exercise, and we've learned how to create, adjust, and panel a mesh.